Hello everyone, this is Harrison Galway, and today I'll be teaching you how to factor quadratic trinomials with a leading coefficient of 1. So before we begin, just a couple vocabulary things to clear up. First of all, what is a quadratic? Well, a quadratic is any expression where the highest exponent is a 2. So if we look at these three examples over here, notice that in the first, the highest exponent is a 1, so that we would say is linear and not quadratic. In the second example, the highest exponent is a 3, so that would be cubic, not quadratic. But in the third example, the highest exponent is a 2, so it is a quadratic. Secondly, we have this term trinomial here. What does that mean? Well, simply that there are 3 terms. So again, looking at our 3 examples, in the first, there are only 2 terms, 1, 2, so we would call this a binomial. In the second, there are 4 terms, 1, 2, 3, 4, so we might call this a four-nomial. Whereas in the third, there are 1, 2, 3 terms, so this here is a quadratic trinomial. Lastly, we make reference here to a leading coefficient of 1. Coefficient is a term that means the number multiplying some variable. So in other words, here the coefficient of this term is a 2, the coefficient of this term is a 3. The leading coefficient is the coefficient in front of the highest degree term. So if we look here, what's the leading coefficient of this expression? Well, that would be a 2. What's the leading coefficient of this expression? Well, it would be a -1. But here, the leading coefficient of this third example is 1. So we're only going to be looking at quadratic trinomials with a leading coefficient of 1. So let's try our first problem here. Notice again we have a trinomial that's quadratic and the leading coefficient is 1. So how do we go about factoring this? By the way, to factor something means to break it apart into things that multiply together to get the original expression. So to factor this expression, all we need to do is find 2 numbers that multiply to our last term here, what we would call the constant term, or c, and add to the coefficient here of this x to the first. We could call this the linear coefficient, or b. So we need to find 2 numbers that multiply to 2 and add to 3. Well, for this problem, there aren't too many choices. If we factor 2, we really only get one way to factor it, 2 and 1. And indeed, if we try those 2 and 1, notice 2 times 1 is 2, and 2 plus 1 is 3. And so we found them. Those are the 2 numbers that will allow us to factor this. So this will factor into x plus 2 and x plus 1. I've just used these 2 numbers here. Moving on to our next problem, and it's really that easy. Our next problem. Again, we have a quadratic trinomial with a leading coefficient of 1. And we need to find 2 numbers that multiply to 3, or c, and add to 4, or b. What are 2 numbers that multiply to 3 and add to 4? Well, again, not too many choices. What multiplies to 3? Just 3 and 1. And when we check those, yes, 3 times 1 is 3, and 3 plus 1 is 4. Voila, we found them. Right, so we'll factor 3 into 3 and 1, and that will be our answer. Our answer will be x plus 3 and x plus 1. And I want to really quickly pause here just to mention that it's very easy to check that you've gotten these factoring problems correctly. All you have to do is multiply your factors together and make sure they come out to the original expression. So, for example, if we multiply these 2 things together, which we would need to FOIL in order to do so. When we do that, well, let's go through the process. X times x is x squared, x times 1 is 1x, 3 times x is 3x, and 3 times 1 is 3. And when we combine our like terms here, we get x squared plus 4x plus 3. Yes, indeed, that is the same thing that we started with, so we can be confident that our factors were correct. On to the next problem. This one is a little bit different because, importantly, our constant term, c, is -12. We always need to be careful to include the negative sign in front of the number when analyzing what that coefficient is. So we now need two numbers that multiply to negative 12 and add to 1. You can't see it here, but the b is 1. So what are two numbers that multiply to negative 12 and add to 1? Well, it's a bit trickier now because when we factor 12, we have more ways to factor it. 1 and 12 works, but also 2 and 6, 3 and 4. And to make matters even worse, we have to have these numbers multiply to negative 12. So one of them is going to need to be negative. So when we look through our options, we need to imagine what two numbers could we add or maybe subtract, since one of them has to be negative, in order to get 1. And when we put it in those words, it's not too hard to see that we could subtract these two numbers. We could do 4 minus 3 or 4 plus negative 3, and that would get us our 1. So we're going to split negative 12 into 4 and negative 3. And our two factors will be x plus 4 and x minus 3. And also notice that 12 had more options, so I just wrote them all out over here, right? We can just write out all of our options and see which one allows us to add to get b. On to the next problem. Two numbers that multiply to 30 and add to negative 11. Well, again, let's just take 30 and factor it out. Also, before we do that, let's notice that we need to multiply two numbers to get positive 30, but add them to get negative 11. So maybe you can think for yourself what that must mean about our two numbers. How could we have two numbers multiply to a positive, but add to a negative? So I'll factor out 30. 1 and 30, 2 and 15 also could work. How about 3 and 10? Maybe 5 and 6, and that, I believe, is all of our options. Which of these two could we use to somehow get negative 11? Well, if we look at 5 and 6, if we make both of those negative, they'll still multiply to 30, but now we can add them to get negative 11, and we found them. So we're going to take 30, split it up into negative 5 and negative 6, and our two factors will be x minus 5, x minus 6. And again, if I wanted to, I could FOIL those two factors to make sure that I get my original expression, but pretty confident about this one. On to our last one. This one looks immediately a bit different than the others, and the reason is because the order that these terms are written in isn't what we're used to seeing. And so what we're going to do is rearrange these terms. We're free to do so. We're going to rearrange these terms such that the exponents are descending or decreasing. So first we'll put the x squared term, then we'll put the x to the first term, and then the constant. Now it looks much more familiar. Same as before, we'll take c, the constant term, and factor it out. So let's see, what can we factor 12 into? 1 and 12, 2 and 6, 3 and 4. And how are we going to use these numbers to get negative 4, right? So we need two numbers that multiply to negative 12 and add to negative 4. We're always careful to include that negative sign when it occurs before one of our coefficients or terms. And so the two numbers that we'll use are 2 and 6, because if we make one of them negative, we can multiply to negative 12. Which one should we make negative, though? Well, if we're adding to a negative number, the larger of the two numbers will need to be negative. So I'll need to make the 6 negative. And let's double check that. Positive 2 and negative 6. Well, the multiplication checks out. They multiply to negative 12. And what's 2 plus negative 6? Negative 4. Perfect. Voila. And so our factors will be x plus 2 and x minus 6. And there you have it. Factoring quadratic trinomials with a leading coefficient of 1. I hope this was helpful. Thank you so much for watching.